Hello and welcome to the AIotHub, your source for all things IoT. Hope you all enjoyed your summer break. We're back now, the heat wave's over. How are things with you, Rajni?
Not bad, just back from Lake District, but I'm actually looking forward to the end of summer.
Okay, is summer particularly painful for you?
In London, it is. Ask anybody. I think we are done with summer now.
Okay, cool. You have some IoT news for us, don't you?
Yes, there is an event in London next week. It's called Connected Britain. And this is a very good participation from both public and private sector in all kinds of technology topics which are very relevant today: connectivity, connected infrastructure, and the new stuff coming up as well. There are some free passes. Generally, the participation is, I think, a couple of grand, but there are free passes also available for those in academia or certain industry sectors. I think utilities is one of them. So some of the audience may find that interesting.
Great, thanks for that. And as I was saying earlier, we're looking for a speaker for October. November should be covered. But if you've got an IoT talk and you'd like to address an audience of 10,000 plus members, then please get in contact with myself, usually via LinkedIn works. One of my privileges on AIotHub is I get to introduce old friends and new, and one of my old friends here is Clifford Agius. Where are you calling in from, Cliff?
I'm in London as well.
Oh, that looks like a fantastic man cave you've got there.
Yes, it is my man cave. Yes, it's yeah, where all the good things happen.
Cliff, I see you having this amazing life because IT is not your full-time job, is it? What is your full-time job?
My normal full-time job is flying aircraft for a major UK carrier. So this morning I woke up in Belfast at 10 to 4. I come back to London, went off to Munich and back, and then come home, got all my stuff out, ready for the talk. So,
well done for staying awake. That sounds like a pretty hectic schedule. So how I imagine your flights are, you say ready for launch, then you take off and you put it on autopilot, and then you're busy coding for the rest of the journey. Is that pretty much how it works?
Yeah, don't let the passengers find out.
Very efficient use of time.
It is. So, yeah. I mean, let's be honest, an aircraft is just a few million parts flying in close formation. It's the biggest IoT geeky thing you play with, which is why I love it. So,
yeah. So Cliff's done some great talks for us in the past. A robotic hand amongst them.
Hold on. It's here. It's handy.
Yeah,
I just pulled out
for
the
a
box
friend of yours.
It's for a friend's son who was born, and all the NHS would give him was one of these. This wasn't propped, it's just the fact that the box is down there. And that goes on his arm. He's missing his arm from there onwards. That goes on his arm, that goes across his back, and as he moves his shoulder backwards and forwards, it pulls the fishing line and opens and closes the hook. That's all you get in the NHS if you're born that way. So we made a bunch of hands. Got another one there. That we then fitted to Caden, and he now uses it as a chef at the moment. So he's chefing things up. And the good thing is he can grab stuff out of the oven at temperatures that me and you can't grab them out of the oven. So yeah. So we've made a few of these now. We're up to 9 in use at the moment. And if you know anyone that needs a hand, literally. Give me a call and we'll see what we can do. We talk about Caden because Caden's family's given us permission to talk about that, but others we just do and help the founders out. So yeah, we're up to 9, and there's another person that we're talking to at the moment that's an elderly gentleman that could do with a hand as well. So that's fun stuff I do when I'm not playing with IoT on my bench here.
IoT improving everyone's lives in every way.
Trying to.
A great story to hear.
Yeah.
So today, what are you coming talking to us about?
I'm talking to you about a project that isn't my project. I've just been heavily involved in it, which is the Moti Me, which is a physiotherapy device for children. And the idea being is that this will help children do their exercises that they need to do. So they could suffer from a condition, cerebral palsy, etc., where they need to do daily exercises to improve their mobility and how they move around. So this is a project from someone up in Nottingham called Katie Michaels. It's her idea. We've been involved, myself and the people who work with me, in building the mobile app, also helping to kind of improve the IoT side in part. And we're looking to make a major change to the IoT that's inside the device, certainly the software anyway, over the coming months. So that's kind of where the project's at. It's about to go live, probably kind of just before Christmas, just after Christmas, is timeline at the moment where it'll be out, and you'll see all the advertising on all the socials, kind of advertising what it is and where you can get one. It's currently being tested by a few hospitals around the UK as part of the NHS. And yeah, I'll go a bit more detail in my talk, but that's what I'm going to talk about today.
Fantastic. Well, we'll let you go on with that. I see Sander's watching from the Netherlands. I'm sure you know Sander.
I know Sander, yes. Sander van der Berg. Yeah. He'll be in orange. He'll be in orange. He's always in orange.
I'm going to say where you're calling in from, and we can ask questions to Cliff live, and we'll pass it over to you.
And where are these questions?
I'll just flash them on the screen.
Right. Okay. Cool. Excellent. All right. I'll look back a bit later then. So we've just gone a bit Inception-like. So let me bring up my slides and talk to you about what this is. So as I say, this slide deck and talk is a bit about .NET MAUI, which is a .NET way of writing mobile apps that cross-platform, Android, iOS, Windows, Mac OS, and Linux now as well. Has just been added recently as a community addition, but also about the IoT side. This being an IoT group, I'll kind of dig a little bit deeper into the IoT side of things than I would if this was a .NET MAUI or mobile app group. My name is Clifford Agius, freelance IoT and .NET developer. I work mainly IoT and MAUI mobile, because let's be honest, your mobile phone that's in your pocket is not just a supercomputer from that you can use to do all the things, not just getting on social and your LinkedIn and your other things, but it's also a fantastic IoT device. All those sensors that are built into that device that are there that you can use, like the angular momentum sensors, the temperature and humidity, dare I say it, all the different sensors that are in there, geolocation sensors from your GPS sensors, etc., your torch and stuff like that, are all part of this amazing device that we carry around in our pockets and stare at all day long. But also, I want to mention Katie Michaels. Her LinkedIn QR code is there if you wish to reach out to her. An amazing person, the founder of the Moti Me project, and she's won the Innovate UK winner, as well as a few other awards as well around this project. And she's the brains behind this. She's pulled it all together. We've just had the privilege of working with her and her team to work on the mobile side, but additionally helping with the IoT side. Certainly the testing, which has been really, really, really interesting, of how to get a medical device tested such that it can be used and be sold on the open market. To do that, some of the things we've had to do within the mobile app to command the device to do has been quite interesting. Just get it through just the testing suite that had to be done. There's bits that I'm not going to show as part of the IoT purely because it's the IP of Katie. She's given permission to talk about the app and the project and the IoT stuff, but there's little bits in there that we're not going to cover just purely because it's her IP and she wants to make sure it's protected, which I totally agree with. It's her project, it's her baby, but she has let us talk about it. A little bit more about Katie. She studied industrial design and up in the north in Nottingham way, and after graduating, she founded the Moti Me project. It was because of her younger cousin was diagnosed with cerebral palsy, and she see the fact that in a family situation that they were struggling with doing the exercises every day because they had to reach and reach back, and they just found it very boring. As anyone that's got a child knows that that watching getting your child to do something, or any child to do something, they'll do it for about 10 seconds. And it's like, I'm bored and I'm going to go off and watch TV or play with a phone, etc. But without doing these exercises, someone with cerebral palsy or other kind of ailments will then struggle in later life, because their body then starts to close up because they're not moving enough. So Katie see the fact that actually, being industrial design, she kind of had this kind of idea to make the Moti Me device, which could then be used to allow the child to exercise, but in a fun way, engaging way, and something that they actually want to do. And it's now become a game, such that they can play this game, and they actually go into their physiotherapy sessions really excited to play the Moti Me game. It started out as a personal project. It's grown into a mission, as you can see there on the screen. That is to design playful, engaging therapy tools to support children's movements, confidence, and development, which I think is quite powerful. We mentioned earlier I've helped build some hands for children, and that the talks that I've done on that and the stuff that's been seen around the internet was one of the reasons that Katie and the team come towards us to help out, because again, this is another kind of tool for helping children. And we're quite passionate about this project as well, because we've seen the smiles on faces. And it was actually given by BBC News East Midlands Today programme, did a section on it. I think this shows more about what the project is and how it's helping children than I can say if I sat here for 2 hours, let alone 1 hour. So it's going to play. It's just a couple of minutes long, and hopefully it should go full screen. Oh, it stopped. Let me try that again.
I'm not getting any sound, Cliff.
You're not? Okay.
No.
Oh, how about now?
No, afraid
No?
not.
Oh, hold on then. Let's where's my if I stop sharing and then start sharing again, would that work?
We're good to go. It worked earlier. We did a sound
audio.
check.
We did. Let me share the app directly rather than if I do that. And
watching East Midlands
how about now?
Yeah.
Award-winning
That working? Yeah.
Yeah.
Has created.
Okay. Let me just go to that then, and if I click play.
Watching East Midlands today.
Let me do this. Let me go to about there. I think was where she was.
Cerebral palsy.
There we go.
Katie Michaels has been a Women in Innovation winner for her work on Moti Me. Now, she's been testing prototypes with children and staff at a special education school in Loughborough, as Emily Anderson reports.
At Ashmount School in Loughborough, Chloe and Harley are playing an important role testing and giving feedback on a new physiotherapy aid. It's called...
What's it doing?
Watching East Midlands today from the BBC, and an award-winning designer in Leicester.
I don't know why it's... Let's try that again. It was about there. Let's click play. I think I've got to keep moving my mouse.
Chloe and Harley are playing an important role testing and giving feedback on a new physiotherapy aid. It's called Moti Me and has been created by Katie Michaels to help children with developmental delay disabilities.
The whole point is to encourage children to practice their movement, their physiotherapy and their stretches. So the idea is it engages with them, it makes it really fun so they don't realise they are practicing their exercises, and it helps them to achieve their developmental milestones. So fundamentally helps with their independence.
Devices like this can make a real difference because our young people have to practice the same physio exercises over and over again. and it can be really dull and actually quite uncomfortable at times. So making it a bit more fun is really great.
Well, the product works alongside this app. Each child has their own profile. There's a page where they've got loads of activities to choose from. In fact, there are over 60. There's also a section where you can track the progress of your child's development. Katie was inspired to create the aid when a family member was diagnosed with cerebral palsy.
Very quickly came to realise how much physiotherapy he had to do every single day to be able to achieve his developmental milestones, such as sitting, standing, walking and crawling. And there wasn't really much out there to help him with that. And we really struggled finding products for him. So that's what inspired me to build Moti Me.
Since then, Katie's been working hard at Loughborough University to research and develop the product using 3D printing for her prototypes.
It means that we can then go into the schools, get some feedback, come back here, redesign it, make a few changes, and then just get it set overnight to have the product ready for the next morning.
So the all-important question, what do the children think of it?
Playing games using the Moti Me with my younger friends has been great fun.
I have enjoyed using the Moti Me. It's so much fun. My favourite animal is the giraffe.
It's nice to use.
Yeah, it changes colour.
Good feedback, and with that in mind, Katie's hoping to launch Moti Me in the autumn for children to use in schools, hospitals and at home. Emily Anderson, BBC East Midlands Today, Loughborough.
How brilliant is Katie? What a great thing to have done.
I'm going to try and go back to my slides now. There we go. So you can see there that you know, that talks about or speaks to the product and what it can do. Inside there's some IoT devices. There's an ESP32 S3 board and some other parts within inside that I'll not cover fully. But obviously there's an LED ring, etc., and some code that's written on that device that then runs and pairs with the mobile app and works. We do have I don't know what is going on with my screen here. So we do have 3 heads that go onto the device. You got the elephant, the giraffe, and the monkey. And the idea is they're for being able to pick up. So some children can't grab things very well, so they may be able to just grab the neck of the giraffe and lift it up and down and place it about on the circles that you have here. The elephant one is if they can just get like a finger, like a pinky inside the ear of the elephant.
Cliff, we're still, sorry to interrupt, we're still seeing the video.
Are you still seeing the video?
Yeah. Do you want to reshare again?
This all worked earlier, didn't it?
It did. We did test this.
Yeah, we did. Let's try again with stopping to share, and then I'll present share screen. If I do my entire screen with audio, how's that? Bit of inception, but we're back, yeah?
Yeah, okay.
Yeah, excellent. Right, good catch. So as I was saying, so we got the giraffe where you can grab the around the neck and just move it around. The elephant where you can put your fingers through and move the elephant around, or the monkey where you grab its ears, you can move it around one ear or both ears. I have the monkey here. It's been tested with over 100 plus children now. It's currently in testing with a NHS hospital, and they're doing some live testing over the next month or two, just to nail down some last parts and last bits need to be done. It's being used with children and young adults, cerebral palsy, autism, Down syndrome. You know, they've got, you know, I think it's well over 100 now prototypes in testing with different units and schools. And the feedback has been highly positive. The kids absolutely love it, as you can see in that video, and that's just a few of the kids that were on camera. You know, the feedback has been amazing, and us playing with it, we quite enjoy playing with it as well here in Cliff Towers. The case study was conducted by Alder Hey Children's Hospital, and they were helping someone with young adult with cerebral palsy, and just using the Moti Me device, he improved his flexibility of his hamstrings and his movement, which then meant that he's now kind of starting to be able to move a lot more. So rather than being fully confined to mobility aids, he now can get you know, he still needs aids, but not as much as he did before. All from just using from a month or two of using the Moti Me device. So you can see it can start to change lives. You can see where it can help improve children. And if nothing else, they're just having fun. They're being kids. You know, you put a blinky light and some sounds in front of the child, and they're like, "What's this? I want to play with it." And that's essentially what the Moti Me device is doing. We're going to cover a little bit about MAUI, because MAUI is what we use to create the mobile app. I know this is an IoT group, but I just want to cover why we picked MAUI. And if you're considering building a mobile companion app to go with your IoT device, which is what, you know, we seem to have done a fair few of them for different clients now, including Moti Me. Why we keep coming back towards .NET MAUI, not just because, you know, I'm a MVP and I work with Microsoft and I work on the team that builds the community toolkit, but purely because like it's got some really strong points. You can see here, if we went down through the different frameworks, .NET MAUI, Flutter, React Native, Uno, Kotlin, and Swift, and you can see the strengths and weaknesses and why we chose .NET MAUI. The major point that we had when we first met with Kate and the team is they wanted a one app that works across mobile, that's Android and iOS. The fact that we gave them Windows and Mac OS as a bonus devices was, you know, really, really good for them. And, you know, they wanted the app to look the same on all devices. They wanted it to be how they wanted it, but equally, they wanted the user of the app, it to be native to them. So if you're an Android phone user or an Android tablet user, you know how the Android ecosystem works. You know that if you long press this or you swipe left with this, you know how it's going to work because you're used to using Android. Someone hands you an iOS device, be that an iPhone or an iPad, you can kind of get around, but those little tricks that you're used to doing are not quite there because you're used to doing it the Android way, not the iOS way. Like, you know, on an iPhone, how do you get to the menu settings? On Android, you swipe down from the top and it's there. On iPhone, you've got to swipe in from one of the corners. You know that as an iPhone user, but you may not know it as an Android user. So the team wanted to encapsulate that as well. So it felt native to that user. And the added part that they wanted was accessibility had to be built in. It couldn't be an afterthought, an add-on, a bit like everyone has with security. You know, if you're building something, it's like, oh, let's sprinkle some security on this. They wanted to have accessibility built in for obvious reasons. So children are, you know, are going to struggle to use an app that doesn't have that built in. So that could be the font size is bigger on their device because, you know, their eyesight. It could be the fact they need the buttons to be bigger because their motor skills are a little bit less and they can't, you know, pause those big, those little buttons that you create. So, you know, or they use a screen reader to read it out to them because they're blind, you know, that sort of thing. You can see one of the children in that video earlier was using a tablet that had it specially laid out for them. So we wanted to make sure that it worked on iOS, on iPhones and tablets. We wanted to make sure that it worked on Android phones and tablets. Windows and Mac OS was just a bonus. It turns out that the NHS here in the UK, National Health Service, use a lot of Windows devices. And so the fact that we could stick it on there and give them a Windows build as well was awesome for some of the test candidates, the hospital settings as well. So you can see why we went through it. We went with .NET MAUI. We have one code base, which is all in .NET and C#, and it works and builds to both platforms, is what we have. So, you know, if you're looking at a companion app, strongly recommend .NET MAUI. If you have any questions, you know, call out to me. Happy to help answer them and help kind of get you on your way with that as well. Let's look at the app initially, and then we'll come back to where that comes into with the IoT device in a little bit. I know I'm talking more of the app side of it at the moment, but trust me, I'll come back to it shortly. So if we go through to Visor, I'm not sure, can you see that on the screen or is he there? Not sure if you can see it or not. Can you see my Visor?
Yeah, it's all good.
Yeah, excellent. All right, so this is an iPhone that's in my hands. You can see me swiping left and right. see some of the apps that we've helped build. And we open the Moti Me app, you kind of generated, see the screen here. I'm using an application just in case you want to ever share your screen over a Teams call, a Zoom call, or a call just like this. It's called Visor, VYSOR. It's awesome, works on Android and iOS, and it just literally, you don't need to plug it in, but the battery is running low when I got this phone out the drawer earlier, and so I need to plug it in for power. But it'll work across Wi-Fi as well, which means you can screen share your device across a call that you may be having to show off an app or something that's going on, or use it as a mobile camera is the other thing. So we click on Let's Start. You can add children, so you can add new children and give them a name. You can see here it's all as it would look on an iPhone. Choose a child's condition, and there's quite a few child's conditions in there. Or we can go back and click on Bob. It's a nice short name, isn't it? And then we've got quite a few activities here. You can see here that Simon says matching and standing. That's a child that can stand up, but they need to kind of reach and stretch. We've got one where they're sitting. We've got another one there that's standing, and then we can go to things like floor time, which is those that are children that are unable to fully support their body, so they may be rolling around on the floor. We can do ones that are sitting, where they're sitting and they reach across, etc. And if we go into one of these, you can see it gives instructions to the parent, the carer, the teacher of how to lay out the spots. And these spots are literally, as you see in the picture earlier, the spots. If I go back to these spots here that you can see underneath the Moti Me device, I'll cover those shortly and what they are. But it shows them how to lay out the spots. So 50 centimeters in front of the child being the star, and it's a sitting position that they use, and they can use the heart there to favorite this app because the child really enjoys it. They can set some times, some color matches, and how many color matches they're going to do, how long the celebration is going to be. And imagine this is you match a color, it celebrates for a little bit of time, and then you match the next color. If you want the child is just starting out, you want celebration time to be quite long, because it allows them to kind of rest between each exercise. If they're getting quite strong at this exercise, you reduce the celebration time down so they can do it quite quick. Now you can imagine like speed running through this, which some of the children do as well. And then there's a description at the bottom which explains what skills and benefits of doing this exercise are for the child, and a little bit of instructions on how to use this exercise and what they're doing with this. So that is the app in picking which exercise. Then there's a journeys page which shows you the progress and activities they've done. I've reset this app because I didn't want it to have all the data in there from testing. So I reset it earlier today purely because it's got some stuff in there. It's IP to Katie and the team. So you can see there some activities, how many days consistent. So you think of this of anyone that's used what's the speaking app that teaches you to speak. I've forgotten what it's called. You'll know what I mean. Speak like different languages, or one of the science apps. Duolingo, that's the one. Thank you. Or the science app that teaches you like all the different sciencey things. Where you've got to be consistent every single day. You've got to be doing your exercises. So that will show all the data, how many minutes they've practiced, how many they've done this week, and then there's some charts down the bottom which they can see, and they can see how many exercises they've done in sitting this week, this month, etc., etc. So it's just giving those activities the progress and what activities they've been doing. There's some there that are just for display, who are in there as well. And the idea is that they can then send this data off to their physiotherapist, their doctor at the hospital, and the parent would send that off such that then they could see, actually, Bob here is doing really well in the sitting. We want to start getting him to do exercises in kneeling. So these are the new exercises we'd like them to do. And then that's where they'll go off and do those exercises. And then we've got settings, which are just some settings that we can set with the device, volume and brightness, that sort of thing. We can set all the Bluetooth when we connect to the device. Diagnostic settings, if you want to set up some diagnostics. And I'll cover the two testing bits at the bottom. a little bit later. But you can do things like, do light testing where you can get the device to respond and test all the lights. Now, because this is a companion app, now if you've built your IoT device, it doesn't have a keyboard, it doesn't have a screen. You can connect it to your PC, with a cable, and you can then send it commands, which are then it's going to respond to. But if you have a companion app, you can do it all from within the app. And because this device is going to be used by non-technical people in a hospital setting, by doctors and nurses and physiotherapists, parents at home, they may not have the tech skills that you and I have. So we need to make this really, really useful. So if they're struggling and they're saying, well, the lights aren't working, the support team say, if you go into the diagnostic settings, do the light testing, or flash the lights, tell us which colour's not working, or tell us if you see no colours, and then we know what's wrong with your device. We can send you the replacement parts. A sound test to make sure the speaker's working, spot matching test to make sure they're all calibrated correctly, mutes on and off, etc. And then you can calibrate the Moti Me, so when it arrives out of the box, you can calibrate the different colour spots to make sure that the Moti Me knows that when you put it on the red spot, that's the red spot. So we have all those. Going back into the diagnostic testing, what we had to do was, because the NHS and other potential customers need this to be a Class 1 medical device, which means it needs to be fully tested, both electrically, electromagnetically for all the different EM noise, etc. It needs to be fully tested. So it had to go into a chamber that can test, and they fire all the different frequencies at it, and we had to make sure that the device could cope with that. But the testing team needed to send the device commands, but unlike where Bob here would be moving it from one spot to the next spot, and then wait 2 or 3 seconds while it plays a tune and the lights flash and celebration, we needed it to do like 20,000 cycles in under 20 minutes. So we needed it to cycle through really quickly. So we come up with a couple of testing modes that are only on our devices here, and the ones that Katie and the team have, and not on devices that go out to, or the app build that goes out to other people. So it's an inbuilt version. And what it allows them to do is start this testing mode, and it will then put Moti Me device on one spot, one specific spot, and then it will go through that cycle really, really quickly. So once it's in the chamber, we can say, right, start the test, and it will just keep doing it. So it's going to keep sending its Bluetooth commands to and from the mobile phone, so they can test that frequency band and make sure there's no interference. It's going to be given off that is not compliant with the laws and regulations, especially in a hotel setting, i.e. The Bluetooth device connection between the Moti Me device and the phone, the RFID tag reader that's in the base of the unit, isn't going to interfere with someone on the next ward that has a pacemaker, for example, or has another device. Maybe they've got a handy device in their hand, suddenly opening and closing. So you can see why it needs to be tested. So that all needed to happen, and we set up these special compliance testing modes within the device. So you can see here, it's quite complex, not just the app, but also the software that's in the IoT device that's within the in the Moti Me device there. So that covers off all the parts of the app. You can see at the top here, we've got a bar along the top, so you can turn the audio on and off. It shows it's connected, and it also shows the battery state. But we'll come back to that in a wee while. What I want to do now is move on to talking about, not the GitHub build, it should have been a slide in there, but I've moved. And we're going to talk about the actual device now. So if I show you this is my OkioCam, which is a little desktop camera used in schools and labs. So you can see here, this is Moti Me, and we can see here a prototype that was built, 3D printed, using Arduino boards inside. So you can see all the Arduino boards inside, and a little speaker is set up there. It's got an LED ring on the top. And this was the early prototype, the V1 device, which, we've all done this with our IoT projects. It's like, well, let's see if we can get something that works. So this was built by Katie and the team, and they had an outside company build the IT side of it for them before we was involved. And from that, they worked out that actually this could work. This could be a good project to work. And then they went from there to the 3D, or not 3D printed, the injection molded parts here, which are injection molded. Katie's quite adamant that she kind of wants this to be a green project as well, and she wanted to support UK industry. So all the parts in there, she wants to try her best to have it either designed, built, or molded in the UK. The injection molded, sadly, if you go to a UK company to get things injection molded, they take the design, build the design into the patterns, and then that's all done in China and shipped across, or there's a couple of other places in the world that it's done. But it's all done from overseas. So Katie went directly to the manufacturers in China and got it done there, just to cut out the middlemen and save. If you're doing a startup, you need to save the money. But you can take the head off, and then inside is the boards, and then there's just an on-off switch and a power, so you can charge the device up. And then the head can be changed from, say, the monkey to the elephant or to the giraffe. We've got the monkey here, and then the LED ring that you see on the top here is underneath the cover here. So if I take this cover off and try and get it out, you can see that it's got an ESP32. It's got an LED ring there, and it's got an RFID reader underneath, and it's quite nicely packaged inside there. Now, this test device, if I can get the cover back on, there we go. This here was working great, and then we had an issue with the battery charging system, and the battery that we had in there was deeply discharged, and we couldn't charge it, and it was an issue with the early versions of the electronics that's inside this device. So we got a new battery, thinking that it's just a normal battery. If I grab one second, the one behind me. So just normal kind of lithium rechargeable battery with the plug on the ends, and we plugged that into the board, and we generated some smoke, which is never a good thing. So we was like, what the hell is going on? Quickly unplugged it, but obviously too late in unplugging it. And it turns out that the where this was put together, the live and neutral have been switched on the early boards. So on the trace that have been made on the early boards, they've been switched around the live and neutral. And in doing so, plugging in a battery that we just got from Amazon, for example, caused some issues. That's obviously now been rectified, but it was just an issue at the time. But it means that this board here is damaged and won't work. So I've got a external battery here, and I'll just use an external battery so you don't think I'm plugging it into the computer and doing some weird stuff. So we just plug this in, and you can see some little LED lights turn on, so it's powered. And we can turn it on, and we see the LED ring will light up, and you'll hear it speak. If I then go to the app and I click on disconnected, reconnect to Moti, or start scan, you can see Moti Me pops up there, plus all the other Bluetooth devices in here. And you can see now, if I move the app across, see now it's gone to a purple there, which is just saying it's ready. Obviously that would shine through if this was on correctly, but it can't because we've got a cable there. If we now go into starting an activity, you can see here, it flashes away and it goes red, which means, I'm not sure if this comes out on the camera, but it is definitely red. And we've got a red spot. So you put it onto the red spot and it flashes, and then it's now looking for a blue spot. So we put it on the blue spot and it plays the sounds. Hopefully you can hear those sounds. It's now looking for the red spot again. So we take this, you see the red spot is over here, and imagine that we're a child, we're stretching for the red spot. There's a red spot, and now it's looking for the blue. So we're stretching back, and now it's the blue, and that is the idea of the game. There's other things it does, which is again IP from Katie, but we'll leave that section there. And then we can, once we've done and it's celebrated, we'll just finish off the game. See, it comes across and it plays a little tune. So my little speaker's loose in there, which is why it's a bit tinny and rattly. And then the app has said that, well, the game's finished for the child. So did the child enjoy it? Did they not enjoy it? Just smiley faces, a little bit of feedback. We're just going to skip that. And that would then go into the application. So, oh, it crashed. That's not a good thing. That's never a good thing, is it? Demo gods have got me again. Just hide that. It didn't crash at all. You didn't see that at all. So you can see here, that's what's inside our application and inside the device. So this was all built, and it's using an ESP32 S3 chipset that's in there, and all the code is written in, if I come back to the, back here, all the code is written in C++, and it's written by another company that have done that for Katie and the team. Problem is that is now embedded on the device. It's really hard to update. You can't do over-the-air updates because it's not possible. You can't do certainly with the way the software is written. If they want to change the order of the spots, i.e., the first two spots of red and blue, if the hospital unit have lost their blue spot, they can't suddenly say we want to replace with a different color spot. We've got a way in the app to do that, but what if we want the device to know and be able to do that as well? So what we wanted to do, and this is the next step, is to switch out the C++ that's in there and switch to using Nano Framework, which means it then becomes .NET, it becomes C#, which means us as .NET developers can then rewrite the code that's in there. It also means that Nano Framework allows you to do over-the-air updates. So the ESP32F3 in there has Wi-Fi and Bluetooth on board. Now the Bluetooth we're using to connect to the mobile phone, but the Wi-Fi we can connect to the hospital network or the school network, and then we can push network updates down to it. Obviously, there's a security that's got to be built around that, and we fully understand that. Or we can get the app to start the updates and push it down to the device over the Bluetooth or over the Wi-Fi. But it allows us to update the firmware on the device. If you're building IoT, you know that there's rules and regulations coming in around security of devices from the EU, which will no doubt come into the UK as well, around device security. So you need to be able to patch the device. Certainly if it has a connection to the outside world, which this one does with a Bluetooth connection. And then add on top of all of that legislation and law, the fact that this is a medical device. You certainly want to be able to patch it and update it. So rather than the users in a hospital having to send these devices back, because again, they're non-technical, send them back to Moti Me and the service team to then just do a firmware update and then send it back to them. Again, Katie is aware that all that shipping backwards and forwards is cost. You've got a van driving around, all the green credentials around that as well. So having the device updatable over the air is quite a big thing. So that's the next thing we're going to do. I'm going to skip a couple of slides because I've realized I've opened the wrong one, and I've added some bits in here for IoT, but these GitHub builds, this is how we build the app on GitHub. So when we push the build up to GitHub, it builds the app and pushes it up to the Google Play Store and the Apple test site for then the testers to build that as well. And notice is an IoT talk, so I'm going to skip through that. We also talk about how all the fonts in the app are, you can see here some of them on the screen, and how we built those using our own way of building the fonts and building our own font pack, our own TTF font pack. So because they were adamant that they wanted the fonts to be a certain way, again, because they need to be such that children could use them and branded, etc. for the app. So we built our own font pack using Inkscape to draw it, and then FontForge to take those Inkscape designs, which are SVG files, into FontForge and then turn them into actual fonts. And we have a special font pack. So instead of putting an A on the screen, the A is now, the left arrow, for example, is effectively what we're doing. And it means that we can control all the fonts within the app as well. So again, clever things can be done if you've been given the reason to make it happen. And there's a video doing it, but we talked about the Nano framework and how we want that to be the software that's on the device. The other thing we want to do is hook it up to Azure IoT Hub. So when the device is being used, we can get some metrics back. Obviously, the personally identifiable information about which child is using it and all that kind of security stuff will not come up to the cloud, which is one of the reasons why we're slow in doing this. because we want to make sure that the data that comes to cloud is purely against the device. How long is the battery lasting? Does the battery need to be replaced because it's starting to wear down? What API version is on device? What API version is on the mobile app that's been connecting to the device? How many times has the device been used? What spot colors are we seeing being used all the time? Do we need to, send them more red spots, for example? All these metrics that can be gleaned from a device. How long is the average use time? What doctors and nurses are using the device the most? Do we need to go and give training to someone who isn't using the device that much, etc.? So that is all part of the IoT side of it. The other side, Entra ID and the API layer, is all more around the mobile app. So when you logged in at the beginning, you see I was already logged in because we do that separately. We want to make that Entra ID. Again, NHS here in the UK and other hospitals kind of around the world and medical placements. Microsoft Entra ID is kind of used the world over, so we can use that. The API layer will then allow us to send the data from the mobile app straight to the cloud, so it can then be stored and shared with, maybe the parents to share their child's experiences at home with Moti Me directly with their physiotherapist. They can do that and it'll appear on a dashboard for the physiotherapist. Again, with the data from the IoT Hub, can enrich that API layer and the data that's seen by the physiotherapist to see that, well, in the app, Bob was using the app, the device on these days, but actually the IoT Hub said that he was using it without the mobile app even more, because you don't always need to have the mobile app connected. It's a companion device, but it's not always required. You can turn the device on and it'll play the last game that was loaded in. So maybe Bob was just playing it because grandma was around. He wanted to show off that he can strut across and pick up the monkey or elephant from the other side of the room now, and bring it back to grandma. That could be extra playtime that's not logged in the app, but we want to make sure we log it. So again, Azure IoT Hub is a great place for that to happen. Sanders here somewhere on the call, and he'll have a field day with all the metrics that will come out of this and show off how to use it in different settings. That's where we're at with the project. Now, I wanted to get a little bit deeper into the code because I know you're all geeks just like me, and we want to talk about the device software. I've got this open from something I was doing earlier, but let's go into the Bluetooth stack. You've all used Bluetooth.
Cliff, that's really, really small. Could we make it a little larger for people?
How about that? Does that work?
Yeah, much better. Thank you.
Excellent. So you've all used Bluetooth devices, your mouse, your keyboard, etc. You know what Bluetooth is. Bluetooth LE is what we're using here. But maybe all of you, not everyone here was watching this knows how Bluetooth works. You have a service layer. So let's talk about your mouse, for example, has a GUID, which is the mouse, the Bluetooth mouse, and that's how your computer knows that it's talking to that Bluetooth device. So it's talking to your mouse. And then you have characteristics within it. Those characteristics could be buttons, left button, right button, mouse move, for example. And you can read and write from those characteristics. Now, not all characteristics are writable, not all characteristics are readable. But in the case of the Moti Me device, we read and write to the same memory location within the device because it's just an ESP32, as I said earlier. So we read and write to the GUID that's there. So these are the GUIDs that are set up within the device, and these are factory ESP32 GUIDs for the Bluetooth stack. So I'm not giving away any secrets here, and we set them up there. We set some within the app, some states for different things, and then we can poll. And I'm just going to skip down to different devices with different GUIDs, and then we set up within the app when the device is discovered. We just set up, and they're just events, just like you do in any .NET program. In a mobile app, you need to run certain things on the main thread because that's the UI thread that you're watching the app. You do it on the background thread, the operating system, Android or Google, Android or iOS can block those background threads talking to the main thread. So you need to run certain things on the main thread, which is the UI layer, so that it works. And if the app is backgrounded because they've got a phone call coming in, you need to then make sure you call back onto the main thread. So that's what some of this is doing. Version changes, and then we will go down to we get the RSSI state of the device, and we've got some Bluetooth commands in here. And then I want to go down to just say device, scanning for the device, connecting to the device. So we've got some calculation takings we set up, and we're setting up some devices, and then we're just connecting to those read and write characteristics, and then we're creating memory state for those characteristics such that we can read the state of the read characteristics. We guard against a double subscription to the read value because we noticed that was causing issues. So we do that, and this is the sort of fun you have with mobile phones. Most mobile phones, it's fine. You connect, and the Bluetooth stack on the mobile device will connect to Bluetooth on the Moti Me or any other Bluetooth stack. But certain phones, and I'm looking at you, Samsung, are a real pain in the backside, and they do some weird and wonderful things. We found that certain Samsung devices that are being tested with would double subscribe, and double subscribing to the right characteristic isn't going to cause any issues because you send the data and it'll arrive at the same place. But double subscribing to the read means every time there's something appear in that memory location, the mobile app is getting alerted twice, which then made the mobile app was like, well, I've got this data twice, therefore it must be 2 different instances of the data. And so we make sure that we only subscribe to it once, and that was why we got this in here. And it's just because of those Samsung devices that was there. We then send LF, which is a simple command which says flash the lights, so light flash, and all we're doing is sending ASCII strings backwards and forwards. I'm not going to go into what they all are, but they're there. The next one that we send is C for commands, and a get, which gets the state of the device. We keep these strings super short, so that they can all fit in one packet that goes across the Bluetooth, rather than being packetized and arriving on device separately. And also, it being super short means that our ESP device that's on board isn't as powerful as your desktop, your laptop, or your mobile phone. It's quite a low-powered device running on a battery. So we keep it short. We can decode the strings really, really simply, and then action those commands. And we do things like, a C for commands is we're commanding the device to do something, which then means it goes down one branch of the code rather than going down all the branches. So it's really easy for the device to look in there. And then we're rehydrating things in case it gets disconnected. And then we're sending commands out. And all we do within the mobile app, when we send the commands, we are tracing it out just so we've got some trace logics. And then we just send it out to the device, and we turn it into, as you can see just here, we turn it into bytes, UTF-8 bytes, and then we write it to the characteristic, and it gets sent on the Bluetooth stack. And that's handled by the mobile device, handles that side of it for us. There's a wrapper within .NET MAUI that wraps it around the Google or the iOS Bluetooth stack. And all we need to do is say, write that to the Bluetooth stack, please, on this characteristic, so this write characteristic, send that data, please, and the OS takes care of that. So we don't care if it's a Google Pixel, Samsung Galaxy S, whatever it is this week, an iOS device, an iPad, Windows desktop, or Mac OS. It's handled for us, and that's the power of .NET MAUI that we come back to as well. I'm well aware that I'm coming towards the end of my time. There were some other bits I wanted to show, which was down here. On characteristic updated, this is when something's being read back the other way. We get that event raised that we set earlier, and we read back in that UTF-8 string. So when the Moti Me device wants to tell the mobile app something, it updates the string. The Bluetooth stack tells the app that something's been updated. We'll read that back in, and then we could pass that. One of the things that took some time to kind of get right was this section here. You can see we've still got the old version in there. Reading in the battery voltages and working out what we want to decide is a 0 volts and what we want to decide is 100 volts for displaying on the. It will go back to the mobile app. Is there? We go back into here, and you can see at the top here. Have I got? Oh, I've got it on there. You can see there that we've got the battery state. What we want to show to the user as being a battery state that is empty or full. So after some testing, we worked out that these millivoltage ranges, 3.35 volts from the battery that's in the production version is close enough to flat that we don't want it to be deep discharge. So we'll tell the person it's 0, and it will still work, without the mobile app, but we're telling them that really they should go and charge it. And then if it gets above this voltage, we're going to tell them it's 100%. Really, it will be above like 4 volts. It will be when it's fully charged. But we want to show it 100% for a little bit longer, because when you turn it on and turn it off a few times, you don't want it to suddenly start saying it's 80% straight away. We all know how battery curves work. So we show it 100% for a little bit longer, and then until it gets about 90% is where this voltage is. So it shows 100%, so the battery is physically at 90%, and then you'll see the decay off. So you hide that kind of drop off at the top where it discharges really quickly, because obviously customers buy this and they want to use it. They don't want it to be looking as if the battery's failing straight away. So that's where we are at with the device at the moment. As I say, it's going to be getting released imminently. Some more things we need to do in the mobile app. We want to the next version of the app we want to put with Nano Framework, which is, if you've not heard it before, it will allow you to write .NET C#. So if you're a .NET developer, you can write your .NET, your C# code, or just your .NET code if you're into F# or whatever, and it will compile down to the binaries that can be loaded onto an ESP32. I've forgotten all the other devices. If you go to Nano Framework website, nanoframework.net, you'll see all the other devices that support. You can, a Raspberry Pi Pico is on there, for example, so you can write C# and compile it down to there, and all the libraries are there as well. So we can work with the LED ring, we can work with the RFID tag reader that's in the base, we can speak to the speaker, we can do the Bluetooth stack. All those parts are in there, and we can then write it all in C#.net, which then means, because we've then got the power of .net, we can have like a class library, we can have like a list of elements that are in there, which means we can update the device over the air. And certainly when we get to Azure IoT Hub and the things we can do there, we can do over the air updates, or even just push updates down. Like, say the child doesn't like the sound that's coming out because they don't like the jingly sounds, they want their own sound and they want it to be, I don't know, Lion King sounds, for example. We can get the app to send the Lion King sound files down to their device. Or they don't like the color yellow and they hate it, they detest it. We can say, right, LED ring, you never show yellow, and we can send that from the mobile app. The way it's written in C++ at the moment, yes, we could get it to do that, but it's a lot more work. Whereas in .NET, it's just a case of, right, just change that sound file from this sound file, and this is the string where the sound file is stored on device. It's a lot easier to do, which is one of the ways we're going to achieve this in the future. So that's kind of where we're at. That's what we're doing. As I say, please do go out to Moti Me, the website, and you can follow Katie and the team out there. If I come back here and go to Moti Me, and you can see the Moti Me family, and you can see all the devices. There's more videos there of the device being used. You can see the young girl there picking it up, and you can see a specialist mat that's been built as well. And you can see the floor time there where they're pushing it because they can't lift it, so they just push it around the mat. You can see all the things they're doing with the device here to build their skills, but also making the activity of exercise fun for that child. I'm on quite a wide screen here, so that's why it's a bit squished up. But you can follow, all the testing that's being done around and all the work that's being done. There's quite a lot of testimonial videos there as well. And hopefully you'll see here shortly when it's going live, and you can sign up on the bottom as join the mailing list. So you'll be told when it goes live what kind of person you are, and be in for becoming either a tester of the device or actually shopping and buying it. In fact, actually, I've noticed there's a shop page. It's not there yet. Obviously, it's coming soon. So you can sign up there to be alerted when the shop opens, and you can buy your Moti Me device. So with that, I'll hand it over to questions. Gone back to the inception. There we go.
Yeah, absolutely fantastic, Cliff. Great public good project. Another one. I'm noticing a pattern. It's fantastic. Yeah, so are they going to commercialize it? I mean, is this going to be going to mass production? Yeah, how is it going to?
Yeah, they've had a few hundred devices made, and they're the ones that are being tested at the moment. So they look just like this. The plastic on this is a little bit too thick, so the light doesn't shine through very well. So they've done things like just simple things like changing the plastic. Again, you know, as engineers, we do things. It's only when you give it to the end user, the child in this case, you know, you'll see the fact that actually they can't see it. So I'm just seeing there's Sander there. Hey Sander, how are you? Thanks for the feedback. So little things like this, the sounds they didn't like. You know, some of the children want to be able to change their sound. So again, we've gone back to how can we do that? Let's look at how we can be able to do updates. You know, maybe they want it to be the sound of their grandma or their granddad, that sort of thing. We can send those sound files down to them, so when they play the game, it's a bit more fun for them. You know, and it changes. It's not a boring device that they put back on the shelf because I'm bored of using it. It changes every week for them. You know, we could put little Easter eggs in there. You know, we know what it's like when we play games. You know, and for children, if you make it fun, they'll keep doing it. They won't get bored and kind of want to go and do something different.
Yeah, absolutely. Rajni?
Yeah, I'm just curious about, obviously this is starting with NHS, but you also mentioned this is Class A medical device. So it means, I'm assuming then Class A medical devices as defined by EU regulations, or is this a global thing? Or if it had to be taken outside of EU, for example, does that require more regulatory work?
Yeah, it's odd. It's one of those there we mentioned Brexit things. It's a Class 1 medical device that's under the EU, but obviously when the UK left the EU, those rules got copied across into UK law. So the UK and the EU is exceedingly close on this. You know, the EU have moved in different areas and the UK have moved in different areas. So it's starting to diverge a little bit, but the testing that's being done, my understanding is it's going to be across the UK and the EU. Obviously, you need to reach out to the Moti Me team to find out for sure. But from the testing that we've been involved in, that's kind of where it's been. All the test results have been done to that standard, such that it can be compliant with both regulations. Certainly, for us going to over-the-air updates and things like this, we do need to comply with the EU regulations. It's a bit more stringent than the UK because you come in just after Brexit. So that law that's required for updating devices is required for the EU. It exists in the UK law, but it's not as impactful, let's say. But yeah.
So I've generally seen that, you know, something which is designed for EU can very easily be adapted for rest of the world, but the reverse is not always the case.
Yeah. So there's thoughts of it going to other parts of the world where it can be used. But yeah, at the moment, I think getting it into the UK market is job number one. EU will be next because that'll be the easier kind of movement, and then kind of rest of the world once they've got kind of those two kind of markets captured. You know, there's quite a lot of kind of technology in there that I'm not showing for obvious reasons to protect the IP of what's going on. But yeah, it's a wonderful project to be involved in. We're really pleased with the team to be involved in it, and we're looking forward to taking it.
Actually, it's really cool.
Yeah. So I don't like working on IoT projects that is just measuring temperature and humidity and putting it up to a data grid somewhere that's sitting and that likes of that.
Who does demos full of that sort of thing, Cliff?
They are. I mean, there's one of the things I hate about IoT demos. Your normal hello world is blinker and LED. Your next one is read temperature and humidity. The next one is send that data to the cloud and show it on a Power BI dashboard. After that, most people give up. And that's why I'm quite passionate about, blinker LED, because that proves you can do GPIO, general purpose input output. But don't start with temperature, or don't stop with temperature humidity. Do get a GPS sensor, get an accelerometer, 6-stop accelerometer, 6 degrees of freedom accelerometer, and use that to show off what you can put to the cloud. I've done this in schools with kids. Temperature humidity, they're all yawning because I'm bored now because I can make it hot and cold. Give them 6 degrees of freedom, and they're saying, "Oh, actually, I could children tells me stuff. If I put this on my tennis racket, I could see how hard I'm swinging the racket when I'm playing, like doing my tennis games." But yes, you could do just that. And child come up with like plenty of products there and then in the classroom, because they've been playing with something a little bit different than temperature and humidity, which for me I find boring. But yeah, so yeah. But everyone knows my thoughts on that. Anyone knows me knows my thoughts on that subject.
Yeah, I've seen your previous presentations, and I thought I'd just get you going a bit.
Yep. I'll get off my soapbox now. So yeah.
Great. Well, we're a little over time. Thank you once again, Cliff, and I hope we'll hear from you again in the future.
Yes. Happy to come back and give other talks about drones and IoT and protecting aircraft.
We all love drones. We need to hear more about drones.
Yes. So I'll come back and give a talk about that.
Great.
Cool.
Okay. With that, we'll hope we see you next month. Okay.
Thank you, Cliff.
Thanks, everyone. Bye.
Bye.
Oh, I've worked out how to get rid of the video now.
Oh, you've dropped someone as well. It was only you.
No, Rajani just left. I think she's.
Oh, right. Okay.
It's, yeah.
Fair enough then.
Over.
Cool.
So, quick question for me: how do you get the you've got the die cast thing? How do you get it to line up with all the components? And did someone else do that?
I'll show you, but it's part of the bits that they didn't want showing off. Is inside the board is, because I can show it's not being streamed. So inside the board is shaped. So they've had the board cut and shaped so that it fits inside the hole. So a lot of the industrial design, and as I said earlier, Katie's an industrial designer by kind of what she does at uni, or